support systems, to name a few. Dr. Mookerjee teaches the graduate core class in information systems and a doctoral seminar in information systems. He's a PhD from Purdue University, and today he'll be talking about user profiling to manage internet advertising campaigns and ad networks. Professor Mookerjee.
Thank you. Can you all hear me? By the way, this is chitika. It is not the banana. So don't say. What is the other one? Chitika. Yeah, Chitika is the company, and banana is. Oh, anyway. But those of you who got confused when they saw the name, they thought I'm working for a banana company. So I should thank Amit, although he's not in the audience, for calling me for this conference. And this association with Chitika was for began in about 2006. And I have done several projects with them. I'm going to talk about two projects today. And they are both to do with user profiling. So unlike the talks that you have heard so far, this talk will be more at an operational optimization level. So we will talk about how exactly we did user profiling, and particularly in the context of how we delivered ads on web pages. So I will talk about two things. I will talk about this one project which I call to show or not to show. Here the basic idea was how we filtered and did not show ads to some users. So that was sort of little revolutionary. Chitika was the first company to do this. Most companies show ads to everybody, but we said, let's step back and think whether we really want to show an ad to this particular user. So this is the to show or not to show. And the other one, which is a more recent project, RTB stands for real-time bidding. This had to do with some new unique challenges that come with regard to user profiling in real-time bidding platforms. So I will talk about that. And these are some of my co-conspirators. Zenson is a PhD student, and the other are all faculty. So let's begin with to show or not to show. What was going on here? So imagine that you are a web user and you go to a URL. You type it in, either type the URL in the address bar, or you go through Google search or something. You end up with a publisher's site. So we'll use the word publisher instead of website, but they are synonymous. Now once you go to the publisher's site, an ad request is placed. So this user, the intention is to show this user an ad. Then this ad request goes to Chitika's geo balancer. So Chitika has many data centers across the US. And after it goes to the geo balancer, it goes to one of the data centers. And from there, an ad is served to the web page. And inside the data center, there is another balancer, a load balancer, which fields the request and passes it on to one of the ad servers. So there may be about more than 100 ad servers in each data center. So that's just to give you a perspective of the scale of the problem and what kinds of prediction challenges arise because we are doing all this in real time. So just to make sure, I'm sure most of the audience knows this, but just to make sure some of the terms, there is the advertiser. An advertiser may be like Sony, maybe like University of Phoenix, etc., a merchant. There is the ad firm. Now here Chitika is the ad firm. We can also call it an ad network. The publisher, which is the website. And of course the web user, you and me who go to websites. So these are different players in this picture. We are going to talk mainly from the perspective of the ad firm here. And usually, in your mind, think of it as a pay-per-click model. So in other words, unless the user clicks on the ad that was delivered, nobody makes money. 98% of the market works like that, so I'm going to focus on the pay-per-click model. Now it should appear that both the advertiser and the ad firm are happy with more clicks. Of course, these clicks should lead to some commerce. They shouldn't be just useless clicks, but assuming the clicks are useful clicks, both the advertiser and the ad firm will be happy if there are more clicks. But the publisher, although the publisher gets paid on clicks, gets no money if there is no click, the publisher also cares about impressions. And what is an impression? An impression is just the delivery of the ad. Now, why is the publisher concerned about impressions and clicks at the same time? The answer is simple. Once you serve an impression, you have basically created an opportunity cost for the publisher. You have used his real estate, and if that doesn't turn into money, the publisher is not happy. So at the end of the month or at the end of a contract period, the publisher says, okay, write me a big check. I'm happy to receive money from you for the clicks, but I would also like to see how efficiently you've been delivering ads. So Chitika, when it was in its early stages, had some problems penetrating the US market. They would go to, for example, Wall Street Journal. And Wall Street Journal would be running the online website. I'm not talking about the print Wall Street Journal. They would be running Google ads probably there. And then Chitika comes, which is a no-name company, startup, and says, use us for part of your web page. Let us show ads for you. So Wall Street Journal would say, fine, but are you going to clutter up my web page with ads which nobody clicks on? I don't want to take that risk. So Chitika came back to them and said that, how about you tell us what efficiency criterion you want. You tell us that I want 1 in every 1,000 ads to be clicked, for example. So that's about a 1% click-through rate. Or you tell us we want a 1.5% click-through rate. So you give us that barrier. We will, over the contract period, try to achieve that barrier, yet make money for you. So at the end of the month, let's think of a month, we'll send you a check, and we promise that we will be as close to that threshold as possible. So that was the business problem that we were given to solve. That how do we approach publishers with this guarantee, efficiency guarantee? So this is mostly a summary that from the perspective of the publisher, only those users that are likely to click on ads are shown ads. That's basically the crux of the solution. That we don't show ads to everybody. We profile the user, and that's why profiling and targeting comes here. We profile the users and say, this user should be shown an ad, this user, we are backing off. So our ad unit is collapsing. Perhaps the content is expanding to fill up that space. So it's not like a blank space with an X box on it. Some graceful backing off is done. But then here there is a trade-off. If we become too conservative about showing ads, that is too much filtering, we filter most users, the immediate impact will be that, yes, our efficiency will be very high. The click-through rate will be high because we'll be more sure that these users will click, but we'll lose money. We'll lose revenue opportunities. In fact, you can, without doing any optimization, you can see that if you want to maximize your revenue, if you want to maximize your clicks, show ads to everybody. So there is that trade-off. How to choose that threshold? So this is just a pictorial way of representing that. Imagine there is a visitor, and the visitor comes with some information. For now, think of this as cookie. So you have cookied that user, and X represents a vector of that information. So the first part of our problem is to estimate how likely is this user to click. So we run it through a prediction model. Then we say, so let P be the outcome of that prediction model. P stands for how likely is this user to click. Then we have two possibilities. Is P greater than some threshold, or P is less than that threshold? And the threshold is a decision variable. So if it is greater than that threshold, we show the ad, else we don't show the ad. Now, once we show the ad, of course, there is no guarantee that the user will click. There's a chance that he'll click. If he clicks, you make money, otherwise you don't. So this is the data analytics part of it, how to build that prediction model. This is the decision analytics part of it. Usually when we talk about big data, we don't very much emphasize the decision analytics part of big data. We focus more on it being a prediction tool, but prediction has to be followed by decision making. What are you going to do with the prediction? You have to make a decision with it. And one thing that happens in the context of ad delivery is that there is feedback. You can see whether for that user there was a click or not. And somehow you can use that feedback to maybe update your decision, your prediction model, or even to update your decision model. So in other words, you can update that regression model which predicts P, or you can change alpha. So this is something a little bit I will tell you about the prediction model. Essentially, there are a lot of predictor variables, and there is some function which maps it to a probability. That's like a regression model. We use logit for this, logistic regression. And these are a subset of the variables. We don't want to give away too much here. So these are some of the variables that were interesting that predicted a click. So as you can see, these have all to do with things which, like the agent the user is using, what browser, etc. Something interesting we found was that this one, button search. This is before instant happened on Google. Remember when you typed, you typically type a phrase or a keyword, and then there are two possibilities. Either you press enter or you press Google search. What we found that those people who press Google search are much less likely to click. Now this is not a causal model or an explanatory model, but correlation is high. So you can guess why that happened. I like to think of it as the dumb effect. So, and then the other one sort of related to that is bad speller. A bad speller is more likely to click than not. Then these are things from the cookie. What is the user interested in, and past history, etc. These are things to do with the ad. Where is the ad? How big is it? Where is it located? Stuff like that. And finally, we want to predict a p value. So this is how the prediction model works. Then the decision analytics, there's a lot of complexity here. I'm going to just summarize it for the interest of time. Increase it, because now we have to be more strict. We've been very lax so far. So think of a door. People are coming into this door, and I open the door and leave some space for people to come in. When they come in, they are expected to do some transaction here. So initially I open the door, say half, and then some people come in, and then I find, oh, they're not really, a lot of riffraff is coming in. They're not really doing what I want them to do once they come in. So I can tighten the door. I can put less space so that fewer people come in, but they're in some sense better selections. So that's where the profiling prediction model gets tied to the decision model. And where is the real-time feedback? I come and see what they are doing in the room.